In this video, we'll be looking at the photoelectric effect. So, what it is that it is the emission of photons from a metal surface when certain frequencies of light are shone onto the surface. So this is the light here going downwards onto the surface, and these are electrons that are flying out. Okay, so it looks like a bit of a face actually. So only it was shown that, or was discovered that lower wavelengths of light allow this process to occur, but higher wavelengths could not. And in order to understand why, we need to look at the equations. So, as the wavelength decreases here, the frequency increases as they're inversely proportional. Okay, so as this frequency increases of a certain photon, then the energy of the photon increases. Okay, so let's look at a graph quickly. Let's look at frequency against kinetic energy of an emitted electron. Okay, and we find that for certain metals, well, it depends on the metal type, there are different, well, all graphs have the gradient h, but there's different threshold frequencies basically for different metals. So for example, that could be potassium, and this one could be aluminium, and this is due to the fact that photons with higher energies can give electrons more energy to escape the metal surface, and this threshold frequency and therefore threshold energy just depends on the type of metal and the strength of the bonds, metallic bonds and things. So the maximum kinetic energy of an electron can be shown by the energy of a photon minus what is known as the work function, or the minimum energy required for a photoelectron to escape. A photoelectron, by the way, is just an electron who has been liberated by a photon, and that's phi, I believe. So this equation just states that the kinetic energy of an electron varies with the energy of the photon, and a constant depending on the metal, which is minused away.